Good morning, everyone. This talk is called Integration over Invention. I basically want to try and convince you to stop building software. So my name is David Dollar. I'm the CEO of Convox. We build an open source infrastructure management system. Before that, I was one of the first engineers at Heroku. I built their support team, founded a team there called Developer Experience, and was responsible for most of the developer-facing design there. I've been working on developer tools and infrastructure for basically my whole career, so this is definitely a topic that's near and dear to my heart. So, like I said, this talk's going to be about software. As most of you know, software is becoming increasingly important for basically every business, no matter what industry. We're starting to see sort of the rise of machine learning, data science, on top of just the normal customer-facing applications that people write, or sort of the back office intranet things that they have to build. And one of the things that I think is becoming really important is that I want you to focus on the things that differentiate your business. So, when it comes time to deploying this software into the wild or building an application that other people are going to use, for the most part, people are building a lot of custom software or tooling to do that. So the thing that I want you to take away from this talk is to really just focus on the things that differentiate your business and to use services for everything else. And so what do I mean by a service? A service is something that you consume as an API. And I think even more importantly, it's something for which somebody else carries all of the operational burden. So I've built a lot of large-scale distributed systems in my time, and this operational burden is basically the most important consideration that you should have when choosing a new piece of technology or deciding to implement something. This is how much time will your engineers need to spend setting it up or building it, and then in the long term, how much time and energy are they going to spend running it, maintaining it, keeping it upgraded, basically maintaining the thing over its life. So let's start by saying, you have some code. You have an application that you built. Maybe it's an intranet app, maybe it's a mobile app, something like that. But you have some code, and you've been building it, and it works great on your laptop. But now you want to deploy it somewhere so that you can make it available to other people. So you have a couple of options to do this. I've got a couple of colors on here to represent different things. Red is something that you have to build yourself. This orangey color is something that you probably didn't have to build, but you have to run. So you need to operate it. If it goes down, you're on the hook for it, bringing it back up. So for a long time, people did most of this stuff on bare metal. You can see you had to build your servers yourself for the most part. You're either building the server or at least racking the server, dealing with all the infrastructure there. And then with all of the supporting infrastructure around your application, like databases or load balancers, or sort of all of this extra stuff, you need to configure it and set it up and then run it over time. So there are some advantages to bare metal. There's certainly a speed or performance advantage sometimes if you're working directly on hardware. You tend to have a lot more flexibility with what you can do or where you can put your servers, or sort of defining the actual characteristics of the thing that you're building. But over the last, say, decade now, we've started to see people really move towards infrastructure providers. Things like AWS, Google, Azure. And so I've added a new color here for green. Green represents something that you can consume as a service, as an API. So if you're on Amazon, you can get ELB or ALB for a load balancer. And whereas on bare metal, you might have set up HA proxy or something like that for yourself and be on the hook for running it. If you're on an infrastructure provider, you can use, say, a load balancer or a database as a service, and somebody else is on the hook for keeping the thing up. You really just consume the thing as an API. So we're starting to see more and more businesses take this approach. I think the last I heard was the last survey of the Fortune 100 CTOs said that 57% of them were using the cloud in some way. with that projected over the next 2-3 years to be more like 91%. We're really starting to see the rise of the cloud in basically every businesses, including ones that were very hesitant to do in the past. So with this approach, you can see there's still quite a few things that you need to run for yourself. You're generally responsible for setting up your own servers and making sure that they stay up, and sort of doing the maintenance and upgrade on those. And I've got this thing down here that says deployment manager. This is basically like if you are setting up Chef or Puppet or something like that to actually take your application code and deploy it. You're building that software, or you're building that tool and setting it up, and you're going to maintain it in the long term. And so even more recently, we've seen sort of these platform as a service companies come into play. This is things like Heroku, Azure websites. You can see basically everything goes green here. Somebody else is managing everything for you. Really the only thing that you're responsible for is your application code. And this is actually pretty great, especially when you're just starting out as a business. You can really just focus on just building your application code and let somebody else take care of really all of the rest. But it does come with some downsides. So there are some downsides. Cost is usually pretty high on most of these platforms. The way that they mark up their resources tends to scale badly over time as you grow. There also tends to be quite a lot of lock-in once you choose one of these platforms. So if you're letting somebody else run all of this stuff for you, it's pretty hard to wean off of that if you ever need to. You also tend to have sort of a lack of control over the actual deployment environment itself. So if you have, say, data residency requirements or sort of operational performance requirements, those can tend to be a lot more difficult to get sort of like the fine-grained control that you want. There's also sort of another downside to really using this like entirely service-based approach, and it's that they can go away. I don't know if any of you built anything on Parse, but anybody who did got a rude awakening one morning, which said that this platform that had been doing all of the magic for them was suddenly not going to be there anymore, and everybody had to scramble to figure out what to do next. So the solution the industry has started to develop is really building sort of these cross-platform tools, tools that allow you to take your application and deploy it to a number of environments. The same code base, but you could deploy it to Amazon or Google or DigitalOcean, wherever you want. And we're also starting to see these tools be more open source. So this open source really mitigates a lot of risk for people adopting these tools. It reduces the risk that it's just going to go away because the source is available to you. It also allows you to modify it if you need to do something that's not already been planned for. So really the best example of this is Kubernetes. So with Kubernetes, you can take Kubernetes, set it up wherever, on your own hardware, on AWS, on Google, and you can take now your code and deploy it to this Kubernetes pod wherever it lives. But as you can see, there's kind of a problem in that you've now taken back a lot of the operational responsibility for running this stuff and setting it up. And really, at the end of the day, that was the key thing that you should be thinking about is this operational burden. How am I going to run this thing over time? What is it going to cost me in time and resources to keep it up, to upgrade it, and to basically to keep it going over the life of the software? So what we've been trying to do with Convox is we're building an open source tool to deploy code like this. But what we're trying to do is really focus on having this single configuration file where you can define everything that your application needs. So I've got a sample web app here. I defined one service. It's built out of the web directory. I defined how much memory it needs and how to scale it, and that there's a Postgres database attached to it. And with one command, Convox deploy, I can deploy it to the infrastructure of my choice. Now, really the difference here is that versus something like Kubernetes, what Convox is doing is going to set up all of these managed services for you. So you can still get the ELB, ALB, you can get RDS for your database. And the way we set this up, it's all completely managed for you. So you can still focus on your application. It really acts like a PaaS, but it's all running on your own infrastructure, your own hardware, and you have total control over it, and there's nothing to go away on you at the end of the day. So the other thing that Convox gives you is we allow you to run Convox start. So using that same configuration file, Convox start will actually take the entire application and boot it up on your local laptop using all simulated versions of all of that same infrastructure, a local ELB, local load balancer, local database, sort of all of that stuff is handled for you. You can really get into this development mode locally where you can pretend that you have all of this extra infrastructure and do all of your development there. So this is actually a pretty short talk. I didn't realize I was going to have an hour, so I'm going to give you back a lot of your time. Really the things that I want you to do are to focus on the things that differentiate your business and to use services for everything else. And that's it. If you have any questions or want to talk about any of this, I'm up here, but a microphone. Yeah. Thanks.
Can you talk about what underlying, cloud providers Convox supports?
Sure. So because we're taking this approach where we actually focus on building towards the specific infrastructure or specific services available at infrastructure, we're doing them one at a time. So we built AWS first, just due to its popularity. And we've got Azure basically in development right now. Probably in the next month or so, we'll be releasing that. So our plan is AWS, Azure, and then Google.
How does the experience compare, say, relative to a Heroku, using Convox versus Heroku?
The experience is very similar. You have the same sort of command line interface. Everything is very application-centric, so you're really just focusing on your app and its code, and all of the other stuff is sort of taken care of for you behind the scenes. So the experience is very similar, except you have control on your infrastructure.
And last question, I promise. What AWS managed services do you support at this point?
Sure. So we actually use almost everything. So basically what we're doing is we're just setting everything up for you in the right way. It's basically, the way we think of it is that this is the thing you would have built if you weren't focusing on the thing you should be focusing on. So yeah, we use auto-scaling groups to keep the servers alive. We tie everything together with a bunch of Lambda automation, that detects problems and restarts things or terminates things. ALB, ELB for the ingress, RDS, Elasticache for data stores. What else? CloudWatch logs for logging. We basically tie together all of the various pieces at Amazon and pull it all together into one package.
So what's the relationship? What's the relationship then between the open source stuff you put out and the paid product, and how does that all work?
So the way it works is essentially the open source bit of Convox turns any infrastructure provider into a REST API. So all of that stuff is open source. And essentially you install that onto, say, Amazon, and the thing that it will expose to you is a very app-centric REST API that our CLI can interact with or you can interact with from your code.
What do you get by paying?
So the way that works is that that API has one basically big master API token that can control everything. Our paid service is basically a management console for all of this. So if you install some infrastructure onto, say, Amazon and Azure, our paid management console kind of lets you, take all of that together and build out, this is my team and this is who has access to what. And this is the audit logs for everything that's happened. And it actually allows you to go in and, if somebody goes and gets a terminal session on your production server, you can actually go and replay that whole session in your web browser and see what's going on. So it's great for anybody trying to do HIPAA or PCI compliance, things of that nature.
Could you just kind of at a high level walk through an example of how like a slightly more complicated web application with like background workers would look like, and how the two would kind of communicate with each other in a Convox infrastructure?
Sure, let's see. So let's go back here. So I didn't really have a lot of space on the slides. I was trying to keep it simple. But essentially, you can define multiple services for your application here. So I would say if I had a worker, I could just define worker, colon, and some other properties here. All of the services scale independently. And then they can also share resources. So in that case, you might have them sharing, say, a backend Redis or SQS or sort of whatever mechanism that the web and worker use to communicate. You can define all of that in this configuration file, and then it'll be created for you.
So does that create like private DNS records and stuff, and then that's how you communicate, or?
Yeah, so it actually does all of that locally. So that's a great question. So we don't do any service discovery with Convox. We do it all through DNS. And the way we do that works both locally on your machine and on Amazon. So if, say this application were named foo, when I start up this application on my local machine, I would get the hostname web.foo.convox that I could hit in my browser. That works locally. And then once I deploy it to Amazon, I can actually use that same DNS name, web.foo.convox, internally inside the application to communicate with that service. We front all of the services that are being used in that way with a load balancer. And so basically the internal DNS points to the load balancer, which then gets you to the backend containers of the service.
Could you talk a little bit about, so I wasn't actually familiar with the development experience and how that tries to simulate the Convox experience in a cloud provider. Mm-hmm. Could you talk a little bit about how that gets put together and what kind of tools are being used there to simulate the real things?
Sure. So they're really simple Docker images that we've put together that basically simulate all of the Amazon services that we need. So we have a service that simulates ELB and can terminate SSL and sort of do all of that. We have a service, Postgres we do as a Docker container and plug it in just like RDS will be later. It's basically just trying to pull all that together. We simulate it with really simple versions that just mimic the API more or less of these services. These things aren't meant to be run at scale. They're not meant to be like run in production. All they are meant to do is let you on your laptop actually run the thing. Cool. All right, that's it. Thank you.